You ready?
Yeah.
All right. The speed is increasing or it's speeding up, meaning the same thing. When the velocity and the acceleration, they have the same sign. When they have the opposite sign, then the speed is decreasing. That's all that the discovery was trying to tell you. All right? But we have it all in one card, so why not? So let's go on to, what page was it? Page 8. Everyone go to page 8. And I'm going to model what this basically is on number 1 and have you partner up for 2 to number 6, and then I'll go over some of them. So here I go. Is everyone ready? All right. Velocity is negative and acceleration is positive. Right, Sam? Notate it. So when the velocity and acceleration have opposite sign, what is happening to our speed? It is decreasing. So on all of the blanks, your answer will either be positive, negative, increasing, or decreasing. So with a partner, let's spend about 2 minutes to fill in the rest of them. And yes, I will go over some of them. And I'll leave this card up here in case you need it. 2 minutes.
Oh, wait. V and A.
So if one is speed's decreasing.
Yeah.
Okay.
Velocity positive.
Oh, it's like 70. Yeah, the next one is down and further the second one. Velocity is positive. Shut up. No, you know what? I'm gonna put like
Right here.
I forfeit. So if velocity is increasing,
Why don't we just take a picture?
positive. Just send it to me. And then I realize you can't send it to me.
Yeah.
How's that my fault?
Shut up.
Cody, work on 2 to 6.
Mm-hmm. I think acceleration velocity is positive.
Moving to the left is
Acceleration.
Velocity is technically speed gets direction. That's what's physics says.
Oh, you did it too.
oh, sheesh.
Wait,
Shut up.
are those minus signs or what?
Yeah.
Oh.
Okay, I'll go over 2 or 3 of them. Give me one. Not all of them.
3.
3? That's a good one.
4, 5.
4 and 5?
2.
4 and 5? Okay, I'll be done with 3, 4, 5. So let's go over them. So as I notate, try to make it somewhat the same. So the velocity is positive. And I'm going to go to my PVA card. And it says the velocity is not just positive, but it's also decreasing. So let's go to velocity is decreasing. If it's decreasing, what do I know about the acceleration? So let's write acceleration is negative. Then I know the speed has to be decreasing because it's got opposite signs. Okay, on number 4, the speed is increasing and the acceleration is negative. So I'm going to focus on that one. The acceleration is negative. And it says our speed is increasing. We know our speed is increasing when the velocity and the acceleration has what?
Same sign.
Same sign, so velocity has to have another negative as well. On number 5, the velocity is negative. And the velocity is also increasing. When it's increasing, what do I know about the acceleration? It is positive. And they have different signs, so the speed must be decreasing. So again, this card is going to wrap up everything from 5 or page 5, 6, 7. Okay, let's do one that's got a graph. And let's analyze first before we start answering. So we have everything about the velocity. So when it's above the 0, velocity is positive. Below 0, its velocity is negative. So let's write out velocity is positive. It is negative right here. It is positive here. And it is negative right here. And I want to talk about this point right here. What is the actual value of the velocity here?
0.
So that means the particle has been stopped. Do I have another location that it's at 0?
Yep.
It's also stopped. Now let's look at the acceleration. Again, acceleration is a slope of the velocity. So from left to right, it's my acceleration going up or down? It is going down. From left to right, is it going up or down? It is going up. So then let's write the relationship of the speed as we compare the velocity and acceleration. So they're opposite sign, so it is slowing down. Where else are we slowing down? The bottom right, opposite sign, slowing down. And then when the velocity and the acceleration has the same sign, what is it doing? Speeding up. And then is the other one also speeding up? Yep. So let's answer the first two on the bottom. On what interval is a particle speeding up? The first one is at 2 to where?
4.
2 to 4, union, and where to where?
6 to 8.
6 to 8. And then where it's slowing down, we have two intervals again. The first one is at 0 to 2. And where's the other one at? 4 to 6. Oops. All right, last page, number 9. Cody, go ahead and read the instruction on example number 1. The graph to the right.
The graph to the right shows the velocity dt of a particle along the x-axis for 0 as well or equal to it consists of a semicircle and 2 line segments. Use the graph and your knowledge of motion to answer the following questions.
So just like we did on the previous page, let's notate everything about velocity first and then the acceleration. So everything above 0, our velocity is positive. What I want you to do is put dots at your extreme points. And some of you guys might say, well, the 0 is not extreme to me. That's fine. I just think every endpoint could also be an extreme point. So I can kind of section them off. So we know the first section here, my velocity is positive. The second one is still above 0, velocity is positive. The third one, what is my velocity? Negative. The fourth one, negative. And then the last one, positive. The acceleration is the slope of the graph. So it's my slope going up or down right here. So acceleration is positive. How about right here? Down. And then right here, down. And then up and up again. Now, one thing that I want to mention right here. What is our slope right there? 0. Okay. Let's see if that even matters to the question we're about to answer. So on number 1, it says, at what time t on the interval between 0 to 11 is the speed of the particle greatest? Now, I did not talk about this one on the PVA card because there's not really a way to, but let's define this. The greatest speed is defined by when the velocity is furthest away from 0. And by 0, it means specifically the x-axis. So that's, if any, something new in addition to your card. So what point on the x is it the furthest from the x-axis? Done. That's it. It's simple to do only if you know the definition behind it. Okay? For number 2, Alan, go ahead and read that out loud.
Of the times t equals 2, t equals 6, or t equals 9 is the acceleration of a particle the greatest.
Let's define acceleration. Right now we have the velocity graph. And acceleration is defined by the slope of the velocity. So we need to find the slope of every single part of it. When t equals 2, what is my slope?
0.
0. When t equals 6, here's my 6 right here. What is my slope? What kind of negative specifically? Negative something over something. 3 over
2.
3 over 2. Y'all can do rise over run, right? Hopefully I'm not too worried about that. When t equals 9 is right here, what is our slope of that line?
3.
3.
1.
And where is my acceleration the biggest? When t equals what number? Isn't that the biggest one? T equals 9. And it says to explain, so I need to write out because slope, of v of t is the greatest. The slope is the greatest. You could say v of 9, but in general, within that graph from the 3 points, that is the greatest. All right, Karis, let's read number 3. All right, so going back to our PVA card, the particle is moving to the left when the velocity is what kind of sign? It is negative, so it's going to the left. So let's write as a note, our velocity must be negative. And our velocity is negative at a certain location that I want to highlight. So it's negative here and negative here. Bless you. So what is our interval then? 4 to 10. And that is because v of t is what kind of sign? Negative. Very good. All right, same our last one. Let's read.
Okay, what time interval is the speed of the particle decreasing? Explain your answer.
So we need to know when the speed of the particle is decreasing. Ooh, the speed is decreasing. So let's go back to our very last card that we made. The speed is decreasing when the velocity and the acceleration has what kind of sign? Different sign. So let's go to our graph where we notated positive and negative. It is opposite here, and it is opposite right here. So we know the first notation is from 2 to what number? 2 to 4. And then our second interval is from 8 to what? Is it 9 or 10? 8 to 10, I see. Yeah? Because v of t and a of t have what kind of sign? Opposite. Very good.